Okay, here is test number 2 for ECE 463-663 Modern Control. In this test, you're to take the gantry system, that's a mass being pushed back and forth with a ball attached to it. This is from homework set number 4. Come up with a control law that has to go back and forth, tracking a sine wave with a constant disturbance. So if you go to Bison Academy, under 463, under test number 2, there's some sample code. This is the starting code. Click on it, opens it up. Bring that into MATLAB. It thinks the code is Welsh. And here's what you should have. You should have 3 files, gantry, gantry display, and gantry dynamics. The gantry display is the same as the previous display routine, but it has 2 inputs, one for the plant, one for the observer, and it draws the picture twice. A light blue one is for the observer, the red one is for the plant. Gantry dynamics is the dynamics for this semester. That has the cart with 4 kilograms, ball 1 kilogram, length 1.3 kilograms, or 1.3 meters, and the main routine. What the main routine does is it has a feedback control law, the observer, for those of you doing problems with the observer, a disturbance. Think about it like a force pushing it to the right. The plane is actually slightly inclined. A control law, the dynamics, the observer, and so on. Now what you should see, kind of the goal of this, is I have a sinusoidal set point going back and forth at 0.5 radians per second. Come up with a control law that tracks it. I have a disturbance. That's a constant pushing it right. Reject the disturbance. And at the A level, do all that while only measuring position and angle. So that's kind of the goal. In terms of the test, here it is. The dynamics from homework set number 4 are as thus. You've got kind of 3 choices. At the C level, assume all the states are measured, meaning that I don't need an observer. Come up with a control axis sinusoidal set point, rejects a constant disturbance, test that control law on the linear system, and test it on the nonlinear system. So when you go into MATLAB, this should be tracking your set point back and forth dead on. That's at the C level. At the B level, it gets a little bit harder. In this case, assume you can only measure position and angle, meaning you need a full order observer. Design a full order observer to track the system, assuming no disturbance. That just complicates the observer. Check your feedback control law plus the observer on the linear system and the nonlinear one. And for the nonlinear system, kind of cheat. Check, assuming you can measure the states, and then the one you really care about is can you just feedback the observer states. And the hardest problem is at the A level, same as the B level, but you have a constant disturbance. And to kind of give an idea of how this all fits together, here's the block diagram of the overall system. At the C level, I don't need the observer, and I just use full state feedback, get this to work. At the B level, I need the observer because they only measure position and angle. There is no disturbance, so this you don't need at the B level. Design a full order observer to track the plant and track a sinusoidal set point. At the A level, it's now do a disturbance, meaning the observer has to estimate that constant disturbance, track a sinusoidal set point, while only measuring position and angle. So that is test number 2. It is not trivial, so don't put it off until Sunday night, but you got a week to work on this. So good luck. And class times this week will just be questions and answers. If you have problems or questions on the test, I'll be available. I'm also available pretty much all the time. Just shoot me an email. I can chat with you on Zoom. Good luck on test number 2.